Part 3 of herbicides mode of action. Dah tak ada suara dah ni. Next is the fatty acid biosynthesis inhibitors, or what you can call as the lipid synthesis inhibitors. This is typically inhibit the synthesis of plant lipids. So lipids are essential components of cell membranes. If lipids are not produced within the plant, then production of cell membranes is unable to proceed and new plant growth is halted. Now this is about the problem. Ariloxy, phenoxypropionic acids, and cyclohexanidones are commonly called FOPs and DIMs, respectively. So, FOPs and DIMs. Okay, each is used for post-emergence selective control of annual and perennial grasses in some dicotyledonous crops and in some cereal crops. They are often referred as graminicides. Okay, herbicides in these groups are foliar applied, readily absorbed, and translocated to meristems, where they are toxic to grasses mainly and have similar selectivity. Observed symptoms in susceptible plants are also similar because both inhibit activity of the enzyme acetyl-CoA carboxylase, so ACCS. So this is important. So this is the term that always occur, ACCS. Okay, I really love this ACCS. One of my friends is working on it. The enzyme, this ACCS, is the enzyme that catalyzes the first step in fatty acid synthesis. So these tables list representatives of these two chemically different but mechanistically similar families. So lipid synthesis inhibitor herbicides primarily are used as post-emergence for grass control in broadleaf crops. Okay, control the grass in broadleaf crops. What can you name some of the broadleaf crops? Okay, they have a high degree of selectivity with little or no broadleaf activity. So these herbicides are absorbed through the foliage and translocated in the phloem to the meristematic regions. The post-emergence grass control herbicides halt meristematic activity by inhibiting the ACCS enzyme that is involved in the synthesis of lipids and fatty acids. Application of the post-emergence grass herbicides tank mix with a broadleaf herbicides often result in reduced grass control, a response called antagonism. So it is also called as tank mix. What is tank mix? Anybody know? Okay, the antagonism can be overcome by applying the separate herbicides several days apart, or by increasing the rate of the grass control herbicide in a tank mix. The injury symptoms caused by the lipid synthesis inhibitors are not evident until several days after treatment, although the plants cease growing soon after herbicide application. Fully developed leaves of treated grass plants may still look healthy for several days after treatment, but new leaves in the whole of the plant will pull out easily, exposing decayed tissue at the base of the leaves. The plants will gradually turn purple, brown, and die, but all the leaves may stay green for a longer time. Drift of sublethal rates of lipid synthesis inhibitors to susceptible grasses can cause a chlorotic band across the leaves in the whole, damage the stems, or kill the main shoot, depending on the dosage and stage of growth of the plants. So have sometimes and look at these descriptions of the plant injury caused by lipid synthesis inhibitors. The pigment inhibitor, next is a pigment inhibitor herbicides. This mode of action works by preventing the production of compounds that protect the plant from chlorophyll destruction. Instead of being green in color, plant tissue turns white. Although injury symptoms are similar with these herbicides, the specific site of action is different. Injury symptoms from the pigment inhibitor herbicides are expressed as white to translucent foliage. Herbicides within this mode of action are typically pre-emergence treatments. However, a few have post-emergence activity as well. Ixoxazolidinones, isoxazoles, and pyridinones make up the chemical families in this mode of action. Common trade names of pigment inhibitors herbicide include Valence, Callisto, and Comans. So these are some of the injuries caused by pigment inhibitors herbicides. The pigment inhibitor herbicides interfere with pigment production and protection of chlorophyll. Ultimately, chlorophyll production is inhibited and plant foliage turns white and appears bleached. Although injury symptoms are similar with this herbicide, the specific site of action is different. So injury symptoms from the pigment inhibitor herbicide are expressed as white to translucent foliage. As I already talked this in the previous slide. So take some time and look at these symptoms and all this the information of it. So these are some other symptoms or injuries. This is the common name, Zorel and Coman, and then this is nulflorazone, and clomazone is the active ingredient. A few herbicides mode of action are classified as unknown. This simply means that we do not understand the mode of action or it has not been classified. MSMA and Notron are the most common herbicide classified as unknown. Some older herbicides are described as having a non-specific action. An unknown mode of action may mean that it is truly unknown, the herbicide has not been studied completely, or the herbicide is too new to know and it is being studied. The mechanism of action is unknown for most inorganic herbicides. Available studies are old and were done with far less sophisticated analytical techniques and less knowledge than modern studies. Most of these herbicides were used for many years, but their use has declined as organic herbicides have been discovered to provide better weed control at much lower rates. Some are still used in mixture with organic herbicides for soil sterilization. So, why you need to understand herbicide mode of action? I'll leave it to you guys to think, to read, and probably we can discuss it. Hopefully we can discuss it in the class.